I'd like to go over Leetcode number 3, longest substring without repeating characters. So essentially what we're given as a parameter in the method definition is a string called s, and we are supposed to return the length of the longest substring, so a string that consists within the larger string, and the length of this string we should be able to give in terms of what the maximum is. And the characteristic of that maximum string will be that it has no repeated characters. So as you can see in here, we have A, B, C, A, B, C, B, B, and there are several substrings within this string that meet the criteria of having unique characters. For instance, we see that BCA is a substring that meets the criteria because it is a substring that does not have any repeated characters, and so is ABC. That too does not have any repeated characters, but BCB has a repeated character, and so does BCBB. So we're trying to return the longest substring without repeating characters, and we want the length of each of those substrings, and we were supposed to find the maximum of all of them. So I wanted to demonstrate this on the board here with a different example. This is usually, if you think of substrings, we're usually ever talking about sliding window problems. Now, characteristically with sliding window problems, we establish a left and right pointer. So, we can have a right pointer here and a left pointer here. Now, initially, they both start at the same place. So what that tells us is that we can come here into the let's see here. So we can come here and actually introduce the right and left pointer. So I'll go ahead and copy the method definition, and we'll work our way here to solving the problem. So we essentially start off with int r is 0 and int left is also 0. And then characteristically, as I said before, what we usually do is we try to move the r pointer down the string, and we keep the left pointer stagnant. And what's going to happen is we're gonna keep moving the right until we find a string that doesn't satisfy the condition of having unique characters. So the right is essentially going to move one up here, one up here, one up here, and it's going to continue doing that. And then we're going to essentially add these characters to a set while we do this. And as soon as we come across a duplicate, we are going to minimize the window to find the next best window that does not have repeating characters. So the presence of the set in this problem is essentially to collect the characters that satisfy the condition. And we'll see why the set becomes more relevant. So we're going to actually introduce the set here. So the set is going to be a set of characters. I'll call it set, and I'll initialize it to new hash set. And of course, we have our angle brackets as well. So while r, which is the right pointer, is less than the length of the string, and since we're calling the length API on s, we actually have to include the brackets, the hugging brackets. For arrays, we actually don't. But while r is less than the length of the string, so while we are able to move r down the string, we are essentially tasked with doing a particular set of operations. Now, the operation is going to be that, okay, if A is not already in the set, then I know that we are part of a substring that does not have any duplicates. And that's really the motivation behind the hash set. As soon as we come across a letter, we ask ourselves, is this letter already contained in the set? If it is, then we are part of a string, or a substring rather, that has repeated characters. So for the very first iteration we can imagine, we can basically say that, if we're going to use the set.contains method that will return true or false on the basis of whether or not a character is already present within the set. So if set.contains is false on the index or on the character that is referenced by the index from the right, if this set does not contain s dot char at right. Now, what is s dot char at right? It's the string s and then the character at what right is pointing to. So if s dot char at right, which is a, is not already within the set, then we can essentially record what the maximum is, right? So we're going to actually have to introduce another variable called max. We'll set this to 0. And then max will essentially be set to, we're going to call the math.max API. Max part of the math utility class. So math.max, it will either be what max was before, or it will be r minus l plus 1. So this is essentially r minus l plus 1 is giving you the length of a particular substring at any given point in time. So as we know, usually when we, in everyday life, if we have, if we have, let's say, a longer stick here, and let's say this is 3 and this is 5, if we wanted to find the length of this, we'll take the right position and subtract off the left. However, since we are part of an array, which includes indexes starting from 0, we actually want to compensate for the fact that we were offset by 1, and so we add 1 back to what we had before. So r minus l plus 1. So if the set does not contain what the right is referring to, record the current length and then increase the amount expand the window that we are looking at. And that is essentially, so, we have right is pointing to the first character. We've recorded what the maximum is so far. It's r minus l plus 1. So right is 0, l is 0. We add 1 to that. The maximum so far is a substring length of 1. Okay. And then this operation is actually repeated. So, we end up moving r up, right? And then we come back, we ask ourselves the same thing. Since r is less than s dot length, we continue this operation. And we say, well, is b in the set? It's not. So we add it to the set. Right, so let me actually make a set here. So we have a and b within the set, and we've added b to the set, and then we move up again, right? Because we've done r plus plus here, and so we ask ourselves, is d already in the set? It's not, so we move r up as well once more, and then we continue doing this. So is m in the set, right? Or is c already in the set? It's not, so we move up. Is m already in the set? It's not, so we move up. So and what we've been doing is we've been adding these to the set. So we have D and C and M. And we actually also want to, what would the maximum be? So the indices 0, 1, 2, 3, 4, 5. Now a string actually doesn't have indices, but we're treating it as if though it does. It's 5 minus 0 plus 1, which is 6. And that is consistent with the length of our string. 3 plus 3 is 6. So our maximum string so far is 6. Now, what happens when we end up moving this right pointer up? What happens when we do that? Well, as you can see, we introduce a duplicate, right? And actually, let me add more letters here. Let's say M or let me say S and K, just so that it's not, this is not an edge case example. But we introduce a duplicate. Now, what you'll notice at this stage is that when we come here and we try to execute this, does the set not contain what the right is pointing to? This will result in a false verdict because the set already does contain D. And so what we want to do essentially is we want to now find the next best window that will satisfy the condition of having unique characters. So in order to do this, it is sort of founded on an observation. And the observation is that suppose you were to move L up from here. Okay, what we see is that even this substring violates the condition, right? Even this substring has 2 Ds. Suppose we were to move L up again once more. Even this substring violates the condition. It also has 2 Ds. Suppose we were to move L up once more, right? Okay, so now we're a part of a string that does not have repeated characters. So what did we just do what we did was we kept removing characters and moving L up until the D was removed, And that will bring us to the next valid substring that does not violate the condition. So what we're essentially going to do here is we are going to say else. So if what the right is pointing to actually does already exist in the set, we are going to save, we're going to call it x, we're going to save this character x is equal to s dot char what the L is pointing to. And while the set contains s, we essentially want to remove, we want to remove set.remove. We want to remove all the characters from the set until the D is deleted. Okay, so we'll remove, or while the set dot contains this character x, so while the set contains D, as we said, we chop off the end. So we'll do set dot remove, and then we'll say remove what s is pointing to, what L is pointing to rather, and then we'll move L up one by one. And so this actually brings us a favorable result. And so if the set does not contain the right, then it's safe to expand the window and record the maximum. But if it does, then we have to chop off everything that came before the duplicate, including the duplicate. So we store that duplicate here. The duplicate that gave us a problem was D, and so this stores D. And then while the set contains this D, we remove everything that L is pointing to, and we move L up, and we do it again. We repeat this process, L++. So we set remove s dot char L, L++. And then eventually we're going to come up here to the while loop, and we're going to say the set no longer contains a D, and then it's safe to come up here and actually add the D to the set because we've removed the unique element. And that's essentially the logic that's been employed here. We've created the set. We have our L, we have our L and R, our right and left pointer. And while R hasn't exhausted the search range, we ask ourselves if what R is pointing to is already in the set. And if it's not, then we can add what the character that R is referring to. We can add that to the set, and we'll record what the maximum is, and then we'll move the right up. Otherwise, we have to go through the logic of recording what this duplicate was, and then chopping off everything from the left, removing it from the set, and having L move up until we don't have this D or the duplicate contained in the set. Eventually, after all of these operations are done, we will be returning what the maximum was.